Good day everyone. So I just finished doing the lab report 7. So the lab introduces the closed loop control system with a compensator added to the system. Unlike the previous experiment in our lab report 6, this setup includes a compensator A of S together with the controller gain K, the plant G of S, and the feedback sensor H of S. The purpose of the compensator is to improve the system performance when a simple proportional controller alone cannot satisfy the design specifications. The characteristic equation and closed loop transfer function were also presented, which help determine the locations of the closed loop poles. So the experiment discusses the root locus and the desired location of the closed loop poles. The design specifications given include a settling time of 2 seconds and an overshoot between 5% and 25%. Using these specifications, desired pole locations so start with were calculated. The page also explains that for a point to belong to the root locus, the angle of A of S times G of S times H of S must equal or to plus or minus 180 degrees. This condition is important in determining whether the desired pole location is achievable. So next is the controller gain K was solved using the previously computed desired pole location. The experiment also analyzed the angle of the open loop system and explained that obtaining an angle equal to an integer multiple of 180 degrees confirms that the point lies on the root locus. After this, a compensator 0 at ZC equals negative 1.19 was added to the system. Adding a compensator 0 changes the root locus shape and helps move the closed loop poles to more desirable locations, improving the system response. Next is the compensated system was analyzed further using MATLAB. So the step response was plotted to observe the settling time and overshoot. The CISO tool of MATLAB was also introduced, allowing easier visualization and adjustment of poles, zeros, and gain values. Additional zeros were added at negative 3.45 and negative 3.72, and the gain was adjusted to improve system performance. This part of the experiment showed how compensators can shape the response of the system and help meet the required specifications. And finally, the report summarizes the computed values such as damping ratio, natural frequency, gain K, and overshoot percentages. The experiment concludes by discussing the effect of zeros on the step response of a standard second-order system. It was observed that adding zeros can improve transient response characteristics such as overshoot and settling time. Overall, the experiment demonstrated how root locus design and compensators are essential in achieving stable and well-performing control systems. So that's all for our lab report 7. Thank you.